Hello and welcome to the project presentation of EEE 458 of Group A. The name of our project is Autocar Parking System with test bin, schematics and layout. I am Samit Hasan and this is my group member Nasim Afroj Taj. We would like to thank our course instructors for letting us the opportunity to work on such an interesting topic. Here is the overall content of today's presentation. Now, let's talk about the problem statement of our project. We had the task to design a smart parking system with a billing system included. We would have to create a account for recurrent users and a post-payment system for users also. All users must put a login password while entering. For accomplishing the given task, we need to take the car number plate as account ID, input the password for entering the parking system. After input of each car number, put the car number to a register to save the car plate number. Make a post payment or prepayment option for users and also keep track of spots. Let's have a look of our approach of the parking system. In the interest of the parking system, there will be a sensor which will be activated to detect a vehicle coming. Once the sensor is triggered, password is requested to open the gate. If the entered password is correct, the gate would open to let the vehicle get in. Otherwise, the gate will be locked. If current car is getting in the park, being detected by exit sensor and another car comes, the sensor will lock the door so that the second car can't enter the parking system at that time. If any car is late to enter the parking system, a green LED will blink apart from the opening the door. If any car is blocked by the system, a red LED will blink to know the car to stop and also the door will be closed. So the workflow of the system will be with the triggering of sensor entrance, the system will be in idle state waiting for the user to put the password. If password is wrong, entry will be denied. If the password is correct, the number plate of the car is registered in the system. While exiting, payment method will be asked to the user. The count number of the registered users will be updated. Here the user can pay for the current bill and also for the previous dues. The required due will be deducted accordingly and let the user exit. If the user doesn't want to pay for the current bill, a due will be added beside the user ID. A register actually keeps the track of all the current number and payment for a specific user, but no user can have a due over than 30. If the due is over than 30, the car parking system won't let the car exit the parking lot. The total available spots will be updated accordingly upon the exit and entry of any car, as you can see in the block diagrams. That if a car enters, then the spot is increased by 1. If it left, they decreased. Okay, now let's talk about the modules of our system.
To perform this task in order, we declared several modules to distribute the task. In the modules are as follows. Car number register module. When a car enters the right password, this module is called with the car number as an input and it returns the register with the car number enlisted in the entry register. Paid car number register modules. When a car wants to pay the bill, this module is called with the car number and the number of payments it wants to pay as input. It returns the register with car number enlisted in the paid list. The entry counter module. Whenever the previous modules return an entry register or a paid list, this module counts the number of entries in the car in both lists. It takes the register and the car number as an input and returns the number of occurrences as an output. Spots register module. Whenever an entry register is returned, meaning a car has entered by the previous modules, this module counts the number of spots left from the previously set total spots. It takes the entry register and the car number as an input and returns the number of spots as after decreasing it by 1 as an output. The main purpose of the state diagram is to take in the password, cross-check it, stop the entry in case of wrong attempt and allow in case of right attempt. Stop the car while it is entering the input, keep track of the empty spots and stop the access when it's full. After a car exits, it goes back to its state again. Main module working principle is at the start, the password, car number, payment status is taken as an input. According to the state diagram, the access is either granted or denied. Then the car number register is called. Then the entry counter counts the number of entries in the register. Then the payment register is called payment status and says the paid now by the car. Then the entry counter counts the number of entries in the register. Then the payment register is called to set the number of payments by the car. entry counter counts the number of payments in the paid list for the car by comparing both number of the entries. If the payment is clear or the month is incomplete, or for the post payments the car exit pass is given, then it shifts back to its state. For the next car, it's of stop and hold. It shifts back to its state when a car exits. Here is our self-checking test bench. We tested it using EDA Playground. We can see for different test cases, the results are similar to expected outputs. Though it's quite tough to understand what is going on from here, we will explain the test bench from our waveforms generated in the next part. Our waveform collected from the EDA Playground. Here is our entry register for the car number entries and the payment register for the paid entries. Here is the input portion, and here is the output portion. Input portion has clock, reset, sensor entrance for car entering the premises, sensor exit for the time period while the car is giving the inputs required, password input, Cadence state, and car number for the registry, local total number of entries of post payment and pre-payment, number of payments of the car wants to do. And here in the output portion, it contains the amount of payment is taken, exit pass, access granted or denied. Now I am going to explain a portion of it here. For the sake of simplicity, we assume 3 maximum entries are acceptable in case of post payment, whereas in reality it will be 30. In each entry, the charge is assumed $3.
First, a car with number plate 12 enters the premises and enters the password 2, which is the wrong password, access denied. Then he enters 1, which is the correct password, access is granted, and car number is registered here as the previous ones were filled before. Then he is asked if he wants post payment or prepayment. He says he wants post payment. So we check that he had 3 entries before and 1 payment before reserved, so 2 dues left for him. So this is acceptable. He is given the exit pass. Then a car with number plate 10 enters the premise and enters 3 as a password, which is wrong, so access is denied. Then he enters the correct password 1, which is correct, so the access is granted and the car number is registered here. Then he is also asked if he wants post payment or prepayment. He says he wants post payment. So we check he has 5 entries before and 3 payments resulting in 2 dues. This is also acceptable, so he is granted the exit pass. Then the car 10 comes again and enters the correct password 1, and the password is accepted and entry is granted. Now when he is asked if he wants prepayment or post payment, he says he wants to pay first and says he wants to pay 3 times. So he is asked for $9 as 3 times 3 is 9, and the entries are here. 3 entries are here, and we can see he has 6 entries now and 6 payments now, so his entry and payment are equal, so his dues list is clear. Then the 12th car comes again and enters the password and says he will correct password and entry is granted, and says he doesn't want to pay now, he wants to post pay. So we can see that he had entrance 4 times and he had paid once, so the difference is 3, so this is also acceptable, so the exit pass is given to him. Then a car number with 14 comes and enters the correct password and the entry is accepted and he wants to pay now. So we can see that he had entered 3 times and paid only twice, so he had only 1 due, so he was asked for $3. He pays it and the dues are clear now. Then a car with number plate 15 comes and at first he had the wrong attempt, entry is not accepted. Then he has a right attempt, entry is accepted. Then the car number is registered here, and then he is asked if he wants to pay now. He says that he wants to pay now, and he had only 1 entry. This is his first entry, but he had paid a previous entry fee, so the dues is clear. He is not charged anything and the payment list is added. Now the car 12 comes again and enters the correct password, so his entry is accepted. He enters the premise, but he doesn't want to pay now either. He wants a post payment, but we can see that he had entered total of 5 times but only paid once, so this results in 4 dues, which is unacceptable, so the exit pass is not given to him. This is a must for him to pay now, either or not he won't be able to exit the premise. And finally we can see the 14th car comes again and enters the correct password. Access is granted. He wants to pay now, and he had one new payment required, so he is charged $3, and the payment register is updated. This is our same waveform in NC-LONGs.
We also performed application-specific integrated circuit front-end design by designing RTL of our system and validated system-level validation using Cadence iOS. Here is a look of our report power report. Our project have 832 cells, and you can see the net power is 7557.14 nanowatt with switching power of 21779.98 nanowatt. In the next slide, we will see the report summary. Here, the report summary where different gates are included. Also, their gate instances, areas, and library file that are used are shown here as well. Now you can see the RTL synthesis schematic view of our synthesized file. In the left, they are the inputs, and in the right, you can see the outputs. As our system had many inputs and many states, the synthesis file schematic looks little bit of complex. Here is the design hierarchy, where the hierarchical order of different inputs and outputs are shown clearly. We also accomplished the physical designing of the system. Here you can see the Innovus layout view of our design system. The left pins are the input pins and the right are the output pins. The die size was chosen of 100 width and 80 height. It was done to avoid DRC errors mainly. It might not be compact, but it was error free. Now you can see the metal fillings and also the added fillers. The strip weight is striped width was set to 0.5 and spacing to 2. We also set the set to set distance to 5 for accomplishing for the layout here. To verify the correctness of the physical design, geometry and connections were verified. Here in the window you can see verify connectivity and verify geometry with 0 violations and 0 errors. Here is the design report after the design layout was filled. No integration constraint in the design was found, as you can see in the report. It was shown. After that, we exported vertical layout to run DRC and LBS. Upon completion of various tasks, here is the actually the schematic view, the vertical layout view. Actually, the layout view of the vertical. Upon completion of various tasks, we finally ran DRC and got this window, no errors, and thus our project came to an end. Let's discuss some of the difficulties we faced, like designing an efficient test bench, selection of core and die size, and the unconnected wires related problem. We will also face some SDC files related problem, as the file when not generated at the beginning. Then finally we could make it from the help of our respected instructor. Facing violations while verifying geometry, and mostly errors that were occurred were the DRC errors, and that was mainly for the spacing errors, which we actually avoided by increasing the die size. It was quite an interesting experience for us to work on this project. At first, we did our logical code in the system Verilog in EDA playground. It worked perfectly as shown in the test bench and waveform, but it proved to be more difficulty for implementing some functions and of system Verilog, such as 2D array input-output, a module containing 2 separate always blocks, functions, and different modules were really tough implementing in Verilog. We had to reiterate our code several times to work it successfully in the Verilog. After all, we actually succeeded to do that. Then we completed RTL synthesis. We have faced some violation and errors in Innovus and verticals, gone through many trials and errors to get an error-free outcome. Through this project, we have learned a lot and discovered many aspects that we have not noticed during the lab experiments. Therefore, then all you have gained through this project has helped us to improve our skills and develop our confidence to work in a more complex task in future. We would like to finish our presentation by thanking both of our course instructors for their constant support and help. Without them, actually, this wouldn't have been possible. Thank you all. That's all for today.